1.6 is about describing pairs of angles. So your essential question is, how can you describe angle pairs and use the description to find angle measures? All right, so before we get started, let's talk about this diagram. This diagram has some marks on it, and you should be able to use those marks to conclude some things about the diagram. So why don't you pause the video now and spend like a minute or two thinking about things that you know for a fact about this diagram based on the markings on this diagram. Okay, so now you have spent a couple of minutes thinking about what you know about this diagram, and let's go over this. So first of all, we know these tick marks right here, and these tick marks mean that the segments are congruent. So we know that segment AB is congruent to segment BC. Or in other words, that their lengths are equal. So maybe you could have written it like this. AB is equal to BC. All right, another thing that we know, because of these arcs right here, we know that the two angles, angle DBE and angle EBC, those are also congruent. So angle DBE will be congruent to angle EBC. Or you could have written it as measures, right? You could have also, if you wanted to use an equal sign, you could have said the measure of angle DBE equals the measure of angle EBC. Those are the same exact statement. Okay, what's this little box mean? Well, that little box means that we have a right angle. So we know that the measure of angle DBA is equal to 90 degrees. Well, in fact, you actually know more than that, because you also know that if this is 90 degrees and angle ABC is a straight angle, right, it's 180 degrees, then that must mean that angle DBC is also 90 degrees. Okay, so we know that angle ABC is a straight angle. Or in other words, we know that the measure of angle ABC is 180 degrees. Therefore, we also know that the measure of angle DBC is equal to 90 degrees, right? So this is 90 degrees. This has to be 90 degrees in order for all of them to add up. Okay, what else do we know here? Oh, I should talk about the fact that because these two angles are congruent, we know that ray BE is an angle bisector. Well, if we're going to talk about that, then what about ray DB? Well, that's a segment bisector. Let's see what else. Oh, because ray BE is dividing angle DBC into two congruent pieces, and because we know that angle DBC is 90 degrees, then each of these angles has to be 45 degrees. So let's see, where can we put that? How about back here? Each of these is equal to 45 degrees, right? So this is going to be 45 degrees. All right, there might be more stuff, but I think we've listed a lot of stuff, and I'm pretty much out of room, so we'll just stop there. And I think we addressed every single little tick mark, little box, little arc, and pretty much everything that we've already covered in this class. Okay, cool. Moving on to complementary and supplementary angles. You've heard this before. Complementary angles. Complementary angles are two positive angles whose measures have a sum of 90 degrees. So complementary angles, two positive angles whose measures have a sum of 90 degrees. In other words, each angle is a complement to the other. Okay, so they can be right next to each other, which means adjacent. Okay, and those two, so angle 1 and angle 2 added together will give us 90 degrees. They're complementary. They don't have to be adjacent though, so they don't have to be right next to each other. They don't have to be touching or sharing a common vertex. So then angle A and angle B here, well, that's 20 degrees, that's 70 degrees. They add up to 90 degrees. They're also complementary. All right, supplementary angles, pretty similar except for it's double. So supplementary angles are now two positive angles whose measures have a sum of 180 degrees. Again, they can be adjacent or right next to each other, where they share that common vertex, like 3 and 4, straight angle forms 180 degrees. Or these two, which are not adjacent, right, but 115 degrees, 65 degrees, those add up to 180 degrees, so those are, in fact, supplementary angles. So just some vocabulary that you need to know. All right, next let's talk about adjacent angles. I think I've already introduced you to this concept because I was just using it. But complementary angles and supplementary angles can be adjacent or non-adjacent. Just like we saw up here, adjacent angles, non-adjacent angles. Now here's the definition of adjacent angles. Adjacent angles are two angles that share a common vertex and side but have no common interior points. So you can see that angle 5 and angle 6, they have a common vertex, they have a common side, this ray they share, right? But angle 5 is over here, so anything inside of angle 5 would be over here. That's not inside of angle 6, right? So angle 6 has points over here. So they don't share any common interior points, but they do share that common vertex and a common side. So you can see that 5 and 6 are adjacent, whereas 7 and 8 don't share a common vertex, don't share a common side, therefore they are not adjacent angles. All right, moving on to the next page. So in the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. So all the vocabulary that we've talked about. So once again, complementary. That means that they are 90 degrees, right? So complementary angles, complementary, I don't think I spelled that right. Let's try that one more time. Complementary. Okay, that basically means the sum is 90 degrees. Okay, well, let's see. Which two angles here add up to 90 degrees? They can be adjacent or not adjacent. So I think, let's see, 28 and 62 degrees, that would add up to 90 degrees, right? So we would have angle GEF and angle ABC. Notice I'm putting the vertex in the middle. I'm naming these correctly. All right, let's do supplementary. Supplementary angles, their sum is 180 degrees. So we need two angles that add up to 180 degrees. So I think, let's see, 108 is close. We need another 72 degrees, right? So those two together would add up to 180 degrees. So that's angle DEG and angle HJK. And then we need a pair of adjacent angles. So we need a pair of angles that share a common vertex and a common side. So let's see, adjacent angles. Okay, so I only see one pair here, right? These two, DEG and GEF, they share that common vertex of E and that common side ray EG. So we'll do angle DEG and angle GEF. Okay, if you have any questions at all, make sure you write some questions out here for me, and then you can ask me when you come to class. And then we can answer them, and then you'll get all your repetitions. Yay! All right, example 2, we're going to find some angle measures. So I know that angle 5 is a complement of angle 3. Well, what that tells me is that the measure of angle 5 plus the measure of angle 3 adds up to 90 degrees. I'll put an A next to this. And I know that the measure of angle 3 is 53 degrees. So this one's 53 degrees. I know that if they add up, they got to be 90 degrees. Oh, I'm not going to put a degree symbol because sometimes I mess up and I think that that's a 0. So I think I'll leave that out. I don't know what measure of angle 5 is. But I know that added together, the sum of these two is going to be 90 degrees. So how do I find the measure of angle 5? You just basically 90 minus 53. So I'm using an equation here to solve, only because they won't always be so easy. Things like that you can do in your head. So the measure of angle 5 is equal to 37 degrees. Okay, so for B, now we know that angle 4 is a supplement of angle 2. So that tells me that the measure of angle 4 plus the measure of angle 2 is equal to 180 degrees. Well, I know measure of angle 4, that's going to be 29 degrees. I don't know the measure of angle 2. And together they add up to 180. So just solve for measure of angle 2, or in other words, 29 plus what gives you 180. So for me, I'll go ahead and solve the equation. And I'm going to get that the measure of angle 2 is equal to 151 degrees. Okay, moving on. So we have the veins in a leaf form a pair of supplementary angles. So here we can see that angle 1 and angle 2, together those form a linear pair, right? That's a straight line. That's a line right there. Okay, so find the measures of the angles when the measure of angle 1 is equal to that and the measure of angle 2 is equal to that. And this is why we set up equations, because we know that angle 1 and angle 2 are supplementary angles. So measure of angle 1 plus measure of angle 2 is equal to 180 degrees because they're supplementary. And now I can't really do this in my head. I know that this plus this equals 180. So I'm going to set up an equation and then solve that equation for x. So the measure of angle 1 is 7x plus 13. The measure of angle 2 is 25x plus 7. And all together, that's 180. And now I'm going to solve this equation just like I normally would. Combine like terms. 7x, 25x, those are like terms. That gives me 32x. 13 and 7 gives me 20. Okay, so now I'm going to subtract 20 from both sides. So 32x equals 160. Divide both sides by 32. And 32 will go into 165 times. I haven't answered the question. All I did was I figured out what x was. The question is find the measures of the angles when these are true. So now in order to find the measures, I've got to go back and revisit these expressions. So how about for angle 1, I've got 7x plus 13, or 7 times, instead of x, I'll put the value of x. Well, that's 38 plus 13. So that's a total of 53 degrees. And now you have an option for angle 2. The measure of angle 2 is supplementary to this. So you can say, you can either plug 5 into there and get a value, or you can also take 180 and subtract the 53. Either way is going to work, and either way is going to give you 132 degrees. So the other way, if you don't want to do it that way, would be to take that 25 times 5 and plus 7. And that's also going to give you 132, because this is 125 plus 7. Great. Okay, linear pairs and vertical angles. So two adjacent angles are a linear pair when their non-common sides are opposite rays. So see how these two are opposite rays here, right? So the angle 1 and angle 2 have a common side, which is that ray in the middle. Okay, well, in between them, I should say, that they share. But they have two sides that they don't share that are these rays that are opposite rays. This is what we call a linear pair. And if you notice, a linear pair is the same thing as a straight angle. Notice the measure of angle 1 plus the measure of angle 2 will give us 180 degrees. That's because this is a straight angle. Okay, the angles in a linear pair are supplementary angles. That's basically a linear pair is a straight angle. Therefore, the two pairs that make up that linear pair have to equal 180 when you add them together. All right, so linear pair form straight angles, supplementary angles. Okay, so together they add up to a straight angle. They add up to 180 degrees. So I guess the definition here is that we have two adjacent angles, non-common sides are opposite rays. Because two opposite rays form a line. Two angles are vertical angles when their sides form two pairs of opposite rays. Okay, so two angles are vertical angles when their sides form two pairs of opposite rays. Notice I've got this vertex in the middle, and I've got two pairs of opposite rays. I've got one pair going, up to the right, down to the left, and the other pair going up to the left and down to the right. So basically these two lines intersect at this point. They form two pairs of opposite rays. Now this becomes really important, and we're going to talk a lot more about this later on, but angle 3 and angle 6 are vertical angles. There's a really special relationship between angle 3 and angle 6 because they're vertical angles, and we'll talk more about that later. Angle 4 and angle 5 are also vertical angles. Again, very special relationship between them. Now angle 5 and angle 6, well, that's still a linear pair, right? They have these two angles share one common side, but their non-common side forms a pair of opposite rays. This is all very important. It's all building on top of each other, and it's all going to come together. All right, identify all of the linear pairs and all of the vertical angles in the figure. All right, so let's start with linear pairs. We're looking for angles that are straight angles, basically. So two angles that form a straight angle, two angles that form a linear pair, two supplementary adjacent angles. Okay, so linear pairs. Angle 1 and angle 2 form a linear pair, right? They form that line right there. They form a pair of opposite rays. Angle 3 and angle 4. Angle 5 and angle 6. Angle 7 and angle 8. There's more though, right? Think about it this way. 1 and 4. 2 and 3. Oh, let me put a comma there. 5 and 8, right? That's another linear pair there. And angle 6 is angle 7. All right, next we're going to have vertical angles. So let's list all the vertical angles. Those are angles, again, that share that common vertex, but they form two pairs of opposite rays. That definition I'm going to keep quizzing you on, so you're going to want to know that. Okay, so angle 4 and angle 2, right, share a common vertex, form two pairs of opposite rays. So angle 2 and angle 4. And in that same area, angle 1 and angle 3 are also vertical angles. Come over to this grouping again. We want two angles, share a common vertex, and then the rays, or the lines that form them, basically form two pairs of opposite rays. So 8 and 6 would be one set. And 5 and 7 would be the other ones. Example 5, two angles form a linear pair. Okay, so right away what I would do if I was doing this problem, if they're not telling me or giving me a diagram, then I'm going to draw my own diagram. Okay, so two angles form a linear pair. That means that I've got two angles forming a linear pair, so I've got a line or a straight angle broken up into two separate angles. I don't know if they're congruent or not. I probably should have read a little bit more. So let's read some more. The measure of one angle is 8 times the measure of the other. Find the measure of each angle. Okay, so they're not congruent, right? One is way bigger than the other. Well, the smaller angle, we don't know its measure. And anytime we don't know the measure of something or we don't know something, this is why we use algebra, is because we can let that just be some variable. I'll let that be x right now. And the other angle is 8 times that measure. So what expression can I put here? Good job, 8x. Now I know together that these two angles, because they form a linear pair, because they form a straight angle, a linear pair forms a straight angle, they're supplementary, they basically add up to 180. So I know that 8x plus x is equal to 180. Notice all the equations I keep setting up. So 9x is equal to 180 degrees. Solving for x, we'll divide by 9, so x is equal to 20 degrees. But I'm not done because I have to find the measure of each angle. So x is equal to 20 degrees, so there's one of them. And the other one, then I just plug 20 in. So this is the same as 8 times 20, or 160 degrees.